Hello everyone. Today we are going to understand what is the gradient descent is and why it is important in machine learning. Yes, it's really important. And this is one of the fundamental machine learning concept that will be asked in interviews or it will be used throughout the machine learning journey. It is the most fundamental thing. Okay. So you can see this graph. I have made this graph and this I hope you can find it really amazing. This is quite beautiful graph you can see here, and we'll be understanding the gradient descent from this. Okay, now let's see what is the gradient descent and yes, first we are going to see some theory and then we are going to do a practical thing. So yes, everything will you'll be getting in the description. So just be with me, see the things, and then understand the amazing concept right now. Yes. So this is the PPT. Of course, we'll be seeing some things like the gradient descent is of course the fundamental technique in the machine learning, um, and that will be enable the model to learn and make their adjustment in the settings. Just think guys how much it is important that it does some adjustment in its model settings, and it actually minimizes the error. So everything is about the error. Okay, so let me tell. I'll be telling you that why this is so much significant. This is because for the reducing the errors. Just think that you are making some predictions and you are getting huge errors. So that is not acceptable. That's why we need to minimize the error to get the real predictions. And everything is on the prediction, guys. Right now, weather prediction is there. You'll be getting some weather details before any weather calamity or something like that. So yeah, that is the about the reducing the errors, then iterative adjustment and finding the minimum. So main thing is about the errors, that how we can reduce errors in the machine learning model. That for that gradient descent works, and this is the algorithm. Okay, now okay, let's go. Yes. So there are some terminologies. Okay. So there is a learning rate, a step size, or something like that. So I'll be giving you a picture. Okay. You can see here is the picture of gradient descent. That how gradient descent works. Not to worry. Um, this is something that okay. Let me tell you from this. Okay. Let's imagine that this is a mountain. Okay, let's take this mountain. Okay, which one? Okay, I will be taking this one. Okay, okay, any. Oh, yes. Let's take this mountain. Okay, let's take this mountain. Here you are standing. Okay, so someone have teleported you there, and then you are just waking up, and okay, you are on this huge mountain, on the top of mountain. The look is really amazing, but you are getting cold. And how you'll be approaching, what we'll be doing. So what you'll be doing is just going downwards. Okay, so you'll be coming downward. Okay, slowly. Okay, so just think that if you are coming like this, here, then you'll be reaching here. Okay, or maybe if you're coming from here, then you'll be reaching somewhat at the base level. So that is what you'll be doing, and that is the same thing gradient descent touch. Yes, I hope you got some understanding of what is the gradient descent. Okay, let me show you. Okay, so it is something like this, and like here you are. Then if you have to go to the minima, then here, then you will be just going like this. Okay, so that is the point, guys. Okay, I hope you got the idea that what is happening. So you will be just going downward. Why it is significant? Because this is called the step size. Okay, this is the called the step size, the steps you'll be taking. Okay, and if a step size, okay, let me tell you that if a step size will be more larger, Just see here. If there are a lot of mountains, then if the step size will be more longer, if then you will be just jumping here and here. So this happens in the case of gradient descent, not in case uh, of course in human. But yeah, if it is giant, then it will be just jumping on other mountain and just coming forth and back, okay. But if it is too much shorter, then it will be just coming very slowly, okay. So it will be taking a lot of time. So that's why we need to maintain a step size that is balanced, okay. So striking a balance is always important in life as well, okay. Now, what is the problem with the gradient descent? What is the problem? Okay, let me tell you. First is local minima. You can see here from this mountain, if you will be going like this, then you will be reaching here. That is called the local minima. This is not the lowest point. This is the lower point. This is not the lowest point. Lowest point is something like this. Okay, you can see here. It's something like this. Here, if you see like this, or maybe it's this is the lowest point you can see. So you'll be just reaching the local minima, not the mini lowest point of the mountain. Yes. So that is the problem with the gradient descent. I hope you got the point of the local minima. Then there are flat areas. On the flat areas, learning got slows down because there is less of a clear direction. Yes. So on the flat areas, if mountain is something like this, then it will be flat, okay, and learning will be become slow down. It will be going slow down, okay. Then if the features have different scales, then it will be also a very uneven learning. What I am telling you, that if in a machine learning model there is a feature, if age is something like 0 to 100, let's take it, okay. But income is something like uh, I will say 50,000. I will say 50,000 to per month to 2 lakhs. Okay. So how much these values are varying? So that is the issue with the gradient descent. Okay. Now there are different ways to use the gradient descent. There are three type of gradient descent. First is batch, then second is the stochastic gradient descent (SGD), and there is a mini batch gradient descent. Okay, so we'll be seeing all these three. Just wait and be with me. Okay. So what the batch gradient does is that it takes the entire data set. Okay, it takes the entire data set at one time and then adjust the setting, but and it is accurate. Yes, that is the good point, but it is quite slow because seeing all the data, you have the thousands of the numbers of the points, then it will be of course slow. Okay, now, if you see the stochastic gradient descent, then what it does, that from huge set of data, it takes the one data. Okay, it takes the one data, and then it sees the one example at a time. It is fast because it is going through one. Yeah, but it is noisy and jumpy. We'll be seeing it in the practical as well. That why it is noisy and jumpy, and you'll be telling that which the gradient descent that is. Okay, and then what the mini batch gradient descent does, that it breaks it in a chunks. Okay, that this is the entire data set. Then it breaks it in the chunks, and then it go through the subsets. Okay, so that is the point. I hope you got the understanding, and this is one of the clearest understanding you will be ever getting. Okay, so let's see just in an overview that batch is slow, high memory, good for a small data sets, of course, because it will be seeing it once. That's it. Now, like in the SGD, it is fast, low memory, of course, and low latency as well, and best for the large data sets because it will be going each of the um, points and real-time updates as well. Yes, But the mini batch gradient is in the medium. Okay, it is striking the balance, and it is of course the most commonly used. Now, this is a tips for the better learning. If you want that your machine learning should be great, or like it should predict um, a good result, and its error should be less, then you have to scale the data. Okay, so every value is on the similar scale. Okay, use so there is a term of normalization. Okay, that is quite used. There is a term normalization that is quite used in the machine learning. So you can just use that, and we'll be learning about. Then there is a learning rate. You have to keep the learning rate best learning rate, um, so that it will be not big and not too small, because it will be causing the instability. Okay, then you can stop early if it is not improving, and you can choose the multiple starting points just to focus here. Okay, so you can use the scikit-learn. Okay, use SGD regressor or SGD classifier, and in the PyTorch and TensorFlow, there is a mini batch gradient descent. Of course, so you can see how the implications are bigger. Like in the machine learning, in the deep learning, everywhere the things are not. I will not saying the deep learning; it's in the machine learning models. Yeah, but yeah, in the deep learning models, of course, we need to have a lower accuracy. And yes, of course, we need to have lower accuracy as well. So this was the thing: step by step learning, types of gradient descent, and effective optimization. So yes, I hope that you got, and this was a lot of theory for the gradient descent. Now we are going to see the codes. Yes, so we love code because we are the developers. So I hope you are enjoying this. Please hit the like button if you are enjoying this. Let's see now. So I just told ChatGPT that okay, I just want to illustrate um our viewers that how the gradient descent works, and this is the picture that how the gradient descent actually works. Okay, you can see here how it is making a step small as it is going towards the minima. Okay, so what it does that I'll just show you from here. Okay, that if someone was going like this, okay, then you need to go more steps. Okay, but when you are going towards this, then you if you will be going like this. Okay, just take like this, then you'll be just jumping down. So when you are going towards the minima, when the slope is down, slope is getting low, then you need to slow down and you need to make your learning smaller. Not here, you need to make learning smaller. And and just to make it okay, okay, just to make it things more clear, just take this, and I'll be taking this. Then here you should be longer, then it should be lesser, then it should be lesser, then lesser, and then small, and then it will be reaching at the perfect minima. But of course, it never reach to the perfect minima as well. That is a one of the thing. um, so yeah, that was the concept. You can see here how it is getting to the lowest of the point, and you can see here how it is achieving the x, and fx is quite less. Okay, so fx is the minima, so it is getting the minima. Okay, now I have told that okay, I just want to show my viewers that okay, we need to show three types of gradient descents. So it took some code, it give me some code, and I have just applied this just to show you. And at this point, I just want to show you this thing, not to code right now, just to understand that what the gradient descent is. Now I just want you to introduce a one formula. You know what happens, that there is okay, okay, I will take some fresh space, maybe. Okay, let's take the last space. Okay, and now I just want you to introduce this formula. Okay, everything is mathematics, guys. So there is a fx and x. Okay, now What happens in the gradient descent? That x new becomes the x old minus alpha, that is the learning rate. Okay, that is actually the sort of a step size, that how much learning it will be happening. And then this is the differentiation or the slope of the fx. Okay, so let me tell you what is happening. So this is the, okay, let's make our mountain more bigger. Okay, so here let's see that if you start a random x. Okay, so this is just a graph. You can see here, this is x, this is y. Okay, now you have taken a random x on this graph. Okay, so you have taken somewhere here. Okay, now what will be happening, that you'll be going like this. Okay, but what will be the x new? If you had taken the random x, then what will be the next step? So next step will be something like this, x old. So this is x old, and what it will be doing, it will be minusing the alpha. Alpha will be constant, and this will be given by the user as well. And it will be actually calculating the uh, slope. Okay, so it will be calculating the slope of this thing. So this is the slope, and slope is actually find out by the differentiation of fx. So yes, you'll be getting the slope, and that is the thing, guys. And yes, that's it. I hope you got some understanding. If you haven't got understanding, please write in the comments below. I'll be making a separate video for explaining this mathematics. But I hope that you got understanding. If not, then please write in the comments. Yes. So that was the thing. Now I'm going to show you the main thing. Yes, you can see here, this is the batch gradient descent, this is the stochastic gradient descent, and this is the mini batch. Okay, so there are not very much of the, you can say, uh, difference between first and third, but there is the difference between second. Can you tell me why? Can you tell me why? It's just because that, I hope you got the point, because it goes on each point, so it becomes bumpy. Okay, so it will be calculating errors and gradient descent. Then that will be actually the bumpy. That's why. Now, the result is explained here. The link will be in the description. Not to worry, just go there and you can use that. And you can, with lecture, you can, with this video, you can uh, access the notebook, of course. And like you we have seen all the things that computationally expensive and all. And of course there are some noise in the mini batch as well. It will be not that much smooth that the batch gradient descent is, but yeah, that's okay. Now, this is the code for the graph generation. You'll be clicking and running it, and then you'll be getting a HTML code. And when you'll be opening the HTML code, then you can get it. Okay. And you can also ask from the chat GPT or DeepSeek that, okay, generate a graph. Okay, so it will be generating. That is quite easy in the age of AI. So I hope you got some understanding. Of course, this video becomes 18 minute of video, but I hope you got some deeper understanding of what is the gradient descent. We explained everything from theory to practical mathematics and some illustrations. If you like this video, then please hit the like button. Send it to your friend who willing to learn gradient descent or machine learning. And see you in the next video. Stay tuned.